So in this question, this is we've been given three planes, and we've got an unknown constant in P here. And given that the three planes do not meet at a single point, so if they do not meet at a single point, then we know that if we convert these three planes into a matrix, so we get that 2p5 1 3 minus 2, and it's that matrix multiplied by x, y, z, which will give us the three planes, and that's going to be equal to minus 2p minus p. Now if we call this first matrix A, and if these three planes do not meet at a single point, then we know that the det of A is going to be equal to 0. Therefore, we can say, okay, let's do the det of A, and so it's going to be 1 times by p multiplied by minus 2, take away 5 times 3, minus, and then there's a minus 2 on the outside anyway, times by 2 times minus 2, take away 1 times 5, and finally it's minus p. So it's plus the last one, but it's minus p, so minus p times by 2 multiplied by 3, take away 1 times by p. And if we now work all this out from the first bracket, so we get minus 2p minus 15, and that minus minus is going to become a plus 2 times by, and you've got minus 4 minus 5 in there, minus p times by 6 minus p, and remember this is equal to 0. Let's put that in there. Right, let's expand further. Minus 2p minus 15, 2 times minus 9 minus 18, minus 6p plus p squared equals 0. And so you've got p squared minus 8p minus 33 equals 0. Factorize this, you get p minus 11, p minus 11, p plus 3, that's equal to 0. So p equals 11, or p equals minus 3. So we found the possible values of p. Identify two possible geometric configurations of the planes stating the corresponding value of p in each case. So we have to consider p equals 11 and p equals minus 3. So let's consider p equals 11 first of all. And then we've got to work out the geometric configuration of the planes. So if we rewrite our matrix with, rewrite our plane, with p is 11. So we're going to get 1, minus 2, minus 11, 2, 11, 5, and 1, 3, minus 2. And that's going to be multiplied by x, y, z to then give us minus 2, p, which was 11, minus p, which is minus 11. Now we can see, the first thing you want to consider is, are any of these lines multiples of the other line, any other lines? Okay, so are two lines multiples of one another? And we can see if we times so 1 times 2, 1 times 2 gives us 2, but then minus 2 times 2 doesn't give us 11. Okay, so the first two are not multiples of one another. Let's look at the next line. So we've got 1, comparing 1 and 3, lines 1 and 3, we've got 1 and 1, they're the same, but then minus 2 is not the same as 3. Okay, and then lastly comparing lines 2 and 3, 2 and half of that is 1, 11, half of that is not 3. So none of these lines are parallel. So no two lines, no two planes are parallel. Therefore, none of them are consistent. Okay. So our next step is to now eliminate one of the variables. So one of the, either x, y, or z. So I'm going to eliminate x. So that means I'm going to eliminate the first entry. So eliminating x. If I want to eliminate x, I'm going to do, I'm going to eliminate it from rows 1 and 2. So I'm going to do row 1, take away row 3. If I do row 1, take away row 3, 1 minus 1, so that's the x term gone. Minus 2 minus 3, so that's going to give me minus 5y. And I'm going to do minus 11 minus 2. Minus 11 minus, so plus 2, so minus 9z. And it's important that you do it to the what they're equal to as well. So it's minus 2 minus minus 11, that gives us 9. Okay. Now I'm going to do row 2, take away 2 times row 3. And again, that will eliminate my x. 11 minus 2 times 3, so 11 minus 6, which is 5y. And 5 minus 2 times 2. So 5, take away 2 times minus 2, so that's going to be plus 4, so plus 9z. And then minus 2, take away 2 times minus 11. So it's not minus 2, ignore that. It's 11 minus 2 times minus 11, and that's going to give me 11. Now we can see that if I, on the left hand side, if I times that by minus 1, I get the left hand, if I times the left hand side of equation number 4 by minus 1, I get equation number 5, the left hand side of equation number 5. However, that's not the case for 9 and 11. If I times 9 by minus 1, I don't get 11. So these are not consistent, or let's just call it inconsistent. And therefore, because they don't intersect at one point, they're not no two planes were consistent. Once we eliminated x, neither of these equations were the same. That means that this must be a prism. So this is the method that we're going to try and use all the time to identify our geometric configurations. Okay, let's try the same thing, same principle for p is minus 3. Now if you got stuck on this question, it would be a good idea for you to try p equals minus 3. Just pause the video and try it yourself. Use the same method that I just did. Compare the matrix for all 3 lines. Then eliminate x, y, or z. And then compare your answers there. Okay, I'm going to do it now anyway. But you could have paused the video and tried it yourself. So let me just say, what have we got here? So now p is minus 3, remember. So I'm going to have 1, minus 2, and then it was minus p, so that's 3. And then 2, and then p, 5. And then 1, 3, minus 2. Multiplied by x, y, z. And that's equal to minus 2 p minus p. Right, and again we can see that if we compare 2 rows, neither of them, any 2 rows, none of them are multiples of one another. And you can quickly see that. So again, no 2 planes are perpendicular, no 2 planes are parallel. Therefore, they're not consistent. Okay, so now I'm going to eliminate x. So the same method we used before. Eliminate x. let's number them 1, 2, and 3. And I'm going to do row 1, take away row 3 again, luckily for us. You don't have to do anything there, just subtract them. Minus 2 minus 3 is minus 5y. 3 minus minus 2 is plus 5z. And minus 2 minus 3 is going to be minus 5. And what I can do is I can cancel that down to give us minus y plus z equals minus 1. And then if I do row 2, take away 2 times row 3, then 2 take away 2 lots of 1, that's fine. So minus 3 take away 2 lots of 3, that's going to give me minus 9y. 5 minus 2 lots of minus 2, I'm going to add 4 there, so that's going to be plus 9z. And you've got minus 3 minus 2 lots of 3, so that's going to be minus 9. And again, if I cancel that down, it gives me minus y plus z is equal to minus 1. And we can see that these two are identical, so they are consistent. And so therefore, when we get consistency at this point, that means this must be a sheaf. So that's how we answer one of these questions. Try and learn that method. That is the method that we use all the time to identify the geometrical configurations of different planes.